Hello and welcome to this video on OOP inheritance and polymorphism, which is part of the series of Python summary. So let's go over to the code and let's start. We create a class. Let's see, change to Python first. Class person. So this is the base class containing generic methods that are shared by all subclasses. So we have a base class, which is the parent class, and we have each class that inherits from the parent class are subclasses or child classes. So there are different terminology for basically the same thing. So let's create an init. Under init, we have a name, which is a string. We have age, which is int. So we do self.age equals age. We do self.name equals name. So here we can create properties similar to in the last lecture. So we have property here, property of age, self. It will return an integer, return self dot underscore age. Well, we don't have self dot underscore age defined yet, so we'll do it in the setter. So let's see, age.setter. Note that in the setter, we need to have the same name as in the property which we defined before. So we had a property here for this decorating this function age or this method age. So then it becomes then we need to use the same symbol. We need to use age.setter. And also I forgot to mention it's in the last lecture, but using the @ symbol, we have a decorator. And basically a decorator is a function which gives an additional functionality to a function. So we have @property is the property decorator. You could have other decorators, you could also create your own decorators, but we won't go through it in our Python summary. So age.setter, so that age self, comma value, int, it returns none. And here we use if not is instance of value, comma number, then we raise, so if it's not a number, we raise a type error. So this is similar to last lecture. So we do an f string here. Age must be int or float, not type. Let's see, type of value. Okay, let's import number. So from numbers import number. And here we do self dot underscore name equals value. So in the beginning, when you instantiate this object, this person object, you put in an age, then the age, we say self.age equals age. Then this will call the setter directly. So the code in the setter will run, which will give us automatically this error checking code, which is really, really good. So we have this error checking when we create this person class and instantiate when we instantiate from this person class. So similarly, let's do it for the age. So add property for the name property. Name, self, let's see, what do we want to return? We return a string and return self._name. And note that in the last lecture, I let the name property, I didn't use, so I used the underscore name directly here. And that's because we did a what's called read-only property, but now I actually want the property to be able to change as well. So this is not read-only. So app name.setter. So that name, self, value. So I want it to be able to change. And also I want it to, I want this error code to run whenever whenever we instantiate from this person. So self, let's self, value. Value is a string. We don't return anything. We return none, like this, right? Name setter. Yes. And here, actually, we have I have some code here for validating. I have I'll paste it in, and I'll explain it. So this code, we need to have import so regular expression. Let's see, like this. So this code, it searches so that we create a name that is valid. So a name that is valid is that it starts with letter. It starts with a letter from A to Ö. This is in Swedish, so we have Ö as well. And then we'll add a space, and then we'll have A to Ö. So we have the whole alphabet, and it should be a space in between, and there could be several of these. So there could be several spaces, and so there could be a lot of names, that is. And then we'll strip for the spaces in the left and in the right to remove those excessive spaces. And if we search for this and it is none, so it means that we don't have a valid name. So we will raise a value error and say that it's not valid. So self._name equals value. And I'll also have say hi self. This will return none. And I'll print f-string. Let's see, f-string, this person, what is this person called? Self.name says hello. Okay, so now I have a person class. I could create the person, p1. p1 equals person of option. I am, say, 42 years old. p1. Yes. So I have a person here. Okay, so now I have my person class. And I want to have a class that inherits from this, which I will do, which I will write next. So I could write, for example, a student. A student inherits from a person. I could write a teacher, a class teacher. A teacher inherits from the class person. So then I will get all these methods for free. Yes. Okay, so moving on to inheritance, we'll create the two classes that will inherit from the person class. So let's create the class student. Class student, this inherits from person. So you just have a parenthesis and you have the superclass, which is the parent class. So def under init. So here, when the autocomplete already gives me some useful code. So we have the name and age attributes, and then we put them into the super of dunder init. So this means that we take the parent's dunder init method. So by doing this, we get all this code for free, all this validation code for free. That's quite neat. And we can also add another attribute to extend this one. For example, we say studies. It's a string. So then we can do self.studies equals studies. So for example, now I could do, for example, S1 equals student of Anna. We say age 126, actually it's 26, but we have mistakenly written 126. Studies AI. What happens? Oh, it worked, strangely enough. So let's see why it worked. 126. Oh, right, I did not add that check. We can add that check also in order to make it not work. So if not value is larger than for example 0, larger than equal 0, value less than equal 125, raise a value error. Age must be between 0 and 125, like this. I run this one, and I run this one. Now we have a value error. Great, that's awesome. Let's do so that we don't. We can do try accept value error as error, print error, like this. So that we don't get all the messiness of the error. Okay, so yes, we got the validation code from our parent class. That's super cool. Let's create a student that will work then. S2, student Uncle Ben. Uncle Ben, and you are I don't know, 70. You want to study data science. S2. Okay, this is student. This is the dunder wrapper. So we could do student of say age 70, S2 dot studies, and we have a data science. Great. Let's create another class. Class teacher. It also inherits from person. You can have the dunder init self. Actually, I want to have the. Oh, right. Person is with big P, capital P. That's why it didn't give me the autocomplete. Dunder init. Dunder init like this. Yes, great. So I want this code. I want to have the teachers also. String. And I will do self.teachers equals teachers. And I will also do another thing. Sorry. I will override this say hi method. So def say hi self print f string teacher self of name says teacher teaches self.teaches, like this. T1 teacher option 33. Let's see, what do I teach? I teach data engineering, for example. It's one thing that I teach. Okay, so we have T1 and we have S2. Let's do a polymorphism. So polymorphism, it's when a symbol name, for example, a function, has different meanings when it comes to different types. For example, the length method, it has, or the length method, it has different meanings for strings and for lists. But we will come in. We'll try this out later. However, I'll show some polymorphism here. And polymorphism, it means different shapes. So let's do like this. We can do people equals T1 and S2. So this is a tuple of a person, of a teacher and a student. So we can loop through this. For people, for person in people, we could do person dot say hi. And we see that we have different methods. We have same name, but it does different things depending on which type it is. So if it's a teacher type, then it does one thing. If it's a student type, it does another thing, right? So other types of polymorphism, I will put into here, polymorphism. We have, for example, what I said with length. We have length of a list, 1, 2, 3. This is 3. We have a length of a string. Hello, this is 5. We can have length of a tuple, etc. We can have hello times 5, and we see that this repeats itself 5 times. We could have 5 times 5, then we have the arithmetic multiplication. 5 plus 5 times 5. So you see that the operator has been overloaded. It's different for different types. So moving on, we will go into operator overloading. Operator overloading. Let's create an example of a vector. So class vector. This vector should have a self as input, and we have, oh right, no, it's we have to create that under init self, and it has star numbers, and these are float. So this is positional arguments, star args. So we can do some validation of this. I won't do all the validation, but I will do some simple ones. So for number in numbers, if not is instance number in the number class, in the number, yeah, from numbers import number, like this. If it's not an instance of number, then we'll raise the type error, a string number not valid element in vector. Like this. And we can also check that the length of the numbers are larger than 0. But I won't do that here. I will make it simpler to save time. So self._numbers. Note that the numbers, note that these numbers, it's a tuple. That's why we could loop it through and we could iterate over it. So self.numbers underscore numbers. So this is the private variable, the backing variable. We will do a generator expression. So we can do float of number. I want to cast it to float, or number in numbers. So we loop through this tuple and we make it into floats. So for example, it could be integer, but we cast it to floats. And this is a generator expression. So for generator expression, we should have tuple in before it so that it becomes a tuple. And here I'll make a property, and use the backing variable self.numbers and just return it. So numbers self, and this will return a tuple. So return self.numbers like this. So v1 equals vector of 2,3. v1, we see that this is the dunder wrapper. We can have v1 dot numbers, and we see that we get the numbers, we get the elements. However, it's quite neat to, let's copy this one and continue. Copy this one, continue here. It's quite neat to have a dunder wrapper. So def dunder wrapper, return f string. What do I want to return? Well, I want to return self.numbers, but I want to return it as a vector, and self.numbers is a tuple, so it will give me the parentheses as well. So if I just write v1 here, I get the vector. That's quite neat. Okay, what else? Well, now we want to do some operator overloading. For example, I cannot do length of v1. Object of type vector has no length. So we need to operator overload the dunder length method. So def dunder length self, it will return an integer, and we just return the length of self.numbers. So we use the read-only property, the getter, and we take the length of it. So as this is a tuple, then the length method will work on the tuple and it will give us a number, and this number will send back whenever we use the length method, a length function. So this gives us 2. Cool. Let's implement something else. Let's do it like this. We put them all together here. So we have vector and we have 2. Let's implement, for example, if I want to do v1 of 1, then we see we have type error because it's not subscriptable. Well, then we do it like this. So def dunder get, let's see, dunder get item. Let's see if it's called dunder get item. I need to look into, yeah, it's called under get item. Self, comma, item, int. So this will return a float because we will get a certain element from this vector, which is a float. So under get item basically return self.numbers of your item. So if I do this, yes, I got 3. Cool. Let's do some addition. Def dunder add self, comma, other. And other is also a vector. Returns a vector. So here we should actually validate that both are vectors. So validate that other also is a vector. That is that you should do, but I don't do that. Validation. Oh, that other also is a vector and has same length. So With the length method and with isInstance, you can create another method for doing this. You could use a static method if you want. However, we'll skip this code. We will do it quite simple here. So what do we want? Well, numbers equals a plus b for a comma b in zip self.numbers, comma other dot numbers, like this. So this is a generator expression. So we do a vector of it, like this. And we can actually, let's do it. No, it's actually like this. You have the numbers. Yeah, you can do. So you have a generator expression, and then you return a vector of star numbers, right? Because then you get each element of this argument, this tuple, and you put it into this to create a new vector. So, for example, I will put it here so that it's cleaner. v2 equals vector of 2,3 and v1 plus v2. And we see, 4,6, perfect. 2 plus 2 equals 4, 3 plus 3 equals 6. Okay, so how did it work? Well, it worked through, because both were vectors, they have a numbers property, and the numbers properties is a tuple, and we zip it through and loop it. So when we iterate it, A will become each element in this first tuple, and B will be each element in the other tuple, and we do A plus B. And here we could do similar thing to do subtraction, dunder sub. We could do dunder mul for multiplication, and in order to have commutative multiplication, we have to implement dunder rmul as well. So this I will leave it like this. So we have a vector class, and we've shown operator overloading. So thank you for watching this video, and see you in the next video. Bye.